Okay, we're now going to talk about one-sided limits. And I'm going to start out with this example here. It was one of the examples that I used to show when a limit does not exist. And so basically here, the limit as x approaches 2 of f of x, we found that that does not exist. And the reason why is that in order for the limit to exist, the function has to be approaching the same value from both sides. Okay, and in this case, as you approach from the negative side, the function approaches -1. As you approach from the positive side, the function approaches a +1. So it's useful then to define one-sided limits, because as it approaches from the negative side, okay, the function does approach -1. So what I could write is that the limit as x approaches 2 from the negative side of f of x, that's actually equal to -1. So as you approach 2 from the negative side, and I have a little negative sign up there, kind of where the exponent would go, then the limit is -1. So this is a one-sided limit. This is coming from the left towards 2. Okay. Similarly here, if I take the limit as x approaches 2 from the positive side, so now I'm putting a plus sign where an exponent would go, then in this case this is taking a one-sided limit from the right, and as you approach from this side, the function approaches +1. And so at least intuitively, this is how you would define one-sided limits. Okay, and basically for the limit as x approaches c of f of x to equal L, for this would be true if and only if the limit as x approaches c from the negative side of f of x is equal to L, and the limit as x approaches c from the positive side of f of x is equal to L. So in other words, the two one-sided limits have to both exist, and they have to approach the same value in order for the limit to exist. And in this case, the limit would be the same value. Okay? So then let's try a couple examples here. So this, we could do a whole bunch of limits. So like here at -2, it looks like this is where this strange function begins, right? If I took the limit as x approaches 2, and we'll call this y equals f of x, I would have to say that this does not exist, because even though it's approaching 1 from the positive side, it's not approaching it from the negative side, right? And then if I took the limit as x approaches 2 from the negative side of f of x, this does not exist, okay, because it's not approaching anything from the negative side. But if I took the limit as x approaches 2 from the positive side of f of x, that would just equal 1, because it's approaching 1 here. So I'm not going to write this out for each one, but you could do it if you wanted to. But just to talk through it, let's consider like this point here at 0, right? As you're approaching from the left side, as you approach 0 from the left side, the limit would equal 0. As you approach from the right side, it would also equal 0. So that would mean that the limit as you approach 0 would equal 0. Okay? And so as you approach 1 from the negative side, the one-sided limit, that would exist and it would equal 2. But as you approach it from the positive side, it would exist. So I'll write this one out. So the limit as x approaches 1 from the negative side of f of x, that actually does exist and it's equal to 2. But as you approach the limit as you approach 1 from the positive side of f of x, in that case, the limit would exist, right? But it would equal just 1 in this case. And so then you could say here, the limit as x approaches just 1 of f of x, that does not exist. Okay? The limits exist as you approach both sides, but they approach different values. For this one here, it's not defined at 2, but you could do the limit as x approaches 2 from the negative side. Sorry, this should just be a negative of f of x. And that would exist, it's just equal to 1, right? The limit as x approaches 2 from the positive side also exists, and that's equal to 1. And in this case, you could say the limit as x approaches 2 of f of x is equal to 1, because it approaches the same value from both sides. The one-sided limit from the negative side is equal to the one-sided limit from the positive side. And so that means the overall limit exists. And so there's all kinds of questions you could ask there. So let's look at this next one. So if you recognize this, anytime you have a number minus x squared underneath the radical, this is a semicircle. So this is actually a semicircle with a radius of 2. So it would start here, it would go up, okay, and it would go down there. And really, for anything between -2 and 2, okay, so the domain here, let me just say, the domain is -2 to 2, right? But for x that's on this interval, for x between -2 and 2, where I could say for x between -2 and 2, the limit would exist for all these values. You could bring it inside, and the limit would exist. There is that root rule, square root rule, or nth root rule that we learned. So for all those that would exist, but the limit, for example, as x approaches -2 of this does not exist. Okay, and the reason is, even though it's approaching 0 from the positive side, it's not approaching from the negative side. So I would have that the limit as x approaches 2 from the positive side of this would equal 0. But as the limit as x approaches 2 from the negative side of this, 4 minus x squared, this does not exist. And you can see why, because if I was approaching from the negative side, these values would be below a -2, and if you plug them in here, then you would get a negative underneath the radical, right? But if you approach from this side, then these values are above the -2, and you can plug them in here, and you would get a positive number. Okay, so it's defined here, but on this side it's not defined. So technically, at the two endpoints here, the limit does not exist, even though at this endpoint, the one-sided limit from the positive side exists, but not the one from the negative side. Similar to this, the one-sided limit from the negative side exists, but not the one from the positive side. Okay? Let me do one more example, and that is this function here. Let's do a one-sided limit as x is equal to -1, or let's do the one-sided limit as x approaches -1 from the positive side. Okay? Now, one thing I want you to notice here is that if I plug in -1 here, I'm not going to get a 0 in the denominator, so as long as it doesn't make this equal to a negative number, we should be okay. We can just plug it in. So if I plug negative 1 in here, I would get a 10, and then this would be plus, and then if I plug in negative 1, I would get negative 21, and so that would give me negative 11. Plug in 11 here, or basically when I put in negative 1 in here, I get 0 under the denominator. I don't get a negative number, I get 0. So I can actually plug in negative 1 into this function, right, and find the limit that way. So this would be 10 negative 1 squared minus 21 times negative 1 plus 11 all over negative 1. And this ends up being 0. So square root of 11 minus square root of 0 all over negative 1. So this is like a negative square root of 11. And I'm going to put here what that is. So if I do negative square root of 11, I get like negative 3.136, so on. So negative 3.1 or 3166, and that would be what it is to 4 decimal places. Okay, so this limit does exist here. Okay, but now what if I did this? I got negative 1 from the minus side. Okay, I would get and I'm going to take it of this. And I would have x on the bottom. So the question is, would this limit exist? And if I use the same logic as I did up here, I could plug in negative 1. I don't get any negatives under the square root sign, no 0 in the denominator. So it seems like this should also equal negative square root of 11. But in this case, it actually does not exist. Why is this? This is a really interesting example. This is a good example to know. Okay? Let me show you. What I have here is I have the function, and I'm going to graph it in the standard window. And it looks like it makes a little jump there. Okay? Do you see that? It like goes down sort of like a square root and makes a jump. And so what it's approaching here, so if I actually hit second calc and I put in negative 1 here, you see that I actually get negative square root of 11. Okay, I actually get that value. Okay, but it seems like it makes a jump up here. So maybe this one-sided limit, should it equal what it is right over here? And the answer is no, because there's not just a vertical jump, there's a horizontal jump as well. Okay, so in other words, if I put in a negative 1.1, so something really close to the left of negative 1, actually, I got something there. Why is that? Negative 1.1. So let me actually, let me do negative 1.01. Maybe that's what I need to do. There we go. Negative 1.01 is, you can see here, is undefined. So I could try something maybe a little bit closer to 1. So I do negative or let me do like negative 1.05, so a little bit further away from negative 1, and oops, sorry, negative 1.05, and you see it's still not defined. See that? It's blank for the y. So let me go even a little further to the left, so I'll do negative 1.09, still not defined. And then when I get to negative 1.1, there it's actually defined, and it's actually defined to be this other graph here. So it looks like there's a space between these two pieces, a horizontal space, not just a vertical space. And so to see why this is, what I'm going to do is I'm going to graph the I'm going to graph. Let me actually go back to show. Oops. So what I'm doing here is I'm graphing the parabola that's underneath the radical, is what I'm doing. So let me hit the graph again. And you see that this goes down, and it looks like it just goes down and touches, but it actually doesn't. If we zoom in on that, it actually goes underneath and back up. And so let's actually do that. Let me take this off. Okay, and let me graph the parabola. And then I'm going to zoom in right there where it crosses the axis. And you can kind of see, it still looks like it almost just touches. Let me zoom in again. Ah, now we see that it goes under the graph. And let me hit zoom again. And as it turns out, these two roots, one of them is negative 1. So let me go to the graph here. If I hit second calc, one of those roots is negative 1. So if I plug it in, you see I get 0. The other one is actually negative 1.9. Oh, let me graph second calc value, and let me do negative I'm sorry, the other root is negative 1.1, and you see you got a 0 there. So this is something that just ducks under, and for this little portion from negative 1.1 to negative 1, the graph is negative. Okay, the quadratic equation is negative. And so that means that underneath the radical, for that little portion, you get negative numbers underneath the radical, which would be undefined. And so it would actually not be in the domain of this function. So what I could do is I could say the domain here looks like it's negative infinity to negative 1.1. And then there's a gap, and then it's 1 to 0, and it's not going to include 0 as well, because 0 gives you a 0 in the denominator, right? So there's actually a gap in the domain here where the function is not defined. And so this graph is actually going, like right here is like negative square root of 11, and this graph is like going like this, and then it actually stops somewhere here, and this point and this point there's a horizontal distance between the two, and this looks like it's a straight line, but it actually is slowly increasing, but it increases very, very slowly, and so you have to zoom way out on the graph before you start noticing that this increases. So that's actually not a constant function here. It's actually defined for both of these points because you can have a 0 under the denominator, and these are the two places where this radical is, where it's 0 underneath there. Between there, then the quadratic equation is negative, and so it can't be defined. So it has the one-sided limit, but it doesn't have the left-sided limit. Okay? So the reason that you can't just plug in -1 here, it seems like you can. You should be able to according to the rules, but those rules, if you look closely at them, the c that you're taking the limit has to exist for at least some small interval around c. Okay? So if you're taking it at c, then it has to be defined around c, not just on one side of c, in order for those rules to work. And that's the condition that this would fail. So this is a really great example. It also shows you just with your technology how you know, you can't just base everything off of technology here. Oops. Let me graph it one more time. Okay. Let me go back. Oops. So let me do the zoom standard again. So in other words, this looks like it's just a little vertical jump. That looks like it might be a constant after that, even though it is slowly rising, and you can zoom out and out and out and you see very little change in that, but it is slowly rising. And so this is why you need to just not rely on technology alone, but on sorry, my son has a PJ Masks watch and the alarm is going off here. Okay, I don't know if you heard that, but okay, it's done though. So this is a great example to show you how all this works together. The technology is helpful. I used it in a lot of different ways, but I was using it in connection with my understanding of the mathematics and the algebra and everything else. So